7.5 is the section you want to be able to do because we use it all the time in past pre-calc. We're solving trig equations. The reason it's the last section in this chapter is because when you get to the medium and the hard problems, you have to use identities to simplify those. Okay? Most of the time we don't have that. We stay in the easy version. Okay? So you've already done some of this. So I could say, solve this equation.
Are we trying to find the radian?
45 degrees.
Yeah, you're looking for the angle measure, right?
So 45 degrees.
Okay. And if you are in radians? 504. Okay, so either of those works. Those are the most simple version of solving trig equations. The function equals the value on a unit circle, right? The calculator version comes into play when you have a non-unit circle value, for instance. Do you remember how to use it? That's stupid. I just did something better. Okay. Let's try that. Solve that equation. 0.65 is not on the unit circle. Do you remember how to do that?
Sine of 0.65.
No. Sine goes with the angle. How do I move the sign across here?
Oh, is it like the negative sign?
The inverse.
So 40?
Inverse. So your calculator has a sine inverse button. Let me see if I can find it here. Okay. Okay, so sine inverse, right? Here's the sine button.
Yeah.
Sine inverse is just above it.
Yeah. Oh, okay, I did it right.
Second, sine inverse. Wait. Oh wait, hold on.
Oh, you're at radian.
We're in radians mode. We need to be in degree mode.
Mine said 40.
Okay, so that's 0.7 radians. Right? That's radians. Not used to seeing that in decimal format, are we? And we can also do it in degree mode. 40.54 degrees. Okay. So then there's a no calculator unit circle versus a calculator non-unit circle question at its most basic. You okay with that, huh? No, I'm tired. I can't. Yes, you can. Deal with it. Here's the next level up. And that is where you're asked to actually move things around, but you're still given something like this, where the sine is the only function inside the equation. Solve for x, what do we do? This is an algebra problem. It's the same as solving an algebra equation.
Can we put that back into tangent?
Right, so add root 3 now. Divide by 2. And where is sine x root 3 over 2? Unit circle question.
So 60 degrees. No, pi over 3.
60 degrees, pi over 3. Okay, where else? In one rotation. So if I restrict this to
120.
2 pi, there are 2 of them. Okay. Be careful here. That is in radians. right?
So, yeah.
What does your answer need to be in? So the acceptable answer here does not involve the degrees. And again, you need to practice that, because in calculus, we don't do degrees at all. Many of you are headed there next year. We're starting to put those lists together. I'll be honest with you, I think it's easier in this class. There's this mental block that everybody has because it's calculus and it has AP in front of it that doesn't need to be there. I'm not joking. I think calculus is easier in this class.
A lot of people say that actually.
That's me. Some people are better at pre-calc than calc, but that's just there's a lot less knowledge, breadth, a little bit more depth. Okay, so there's an example of an easy equation that you can solve. Okay. Here's one. Why don't you guys go ahead and try it? And let's restrict it to now let's go 360. So we're in degrees now, right? Okay. Ready, set, go. And I will assist anyone that might need it.
What's that number at the end? 360.
Yeah.
Okay, just like make sure. It's just 1, 2.
No, it's 1/2 cosine.
Cosine 1/2.
Oh,
which
you're
is,
Yeah.
60 degrees, 300 degrees, 60 degrees, 300 degrees. 120 has to be. It's not 120, because 120 is negative. Yeah, that would work, right? It's 60 and 300.
No, yeah.
I was thinking that. I was thinking 1%.
What's cosine equals? So those of you that are struggling, the first step is to get cosine x equals. What is that?
And you add the 1 divided by.
So we add 1, and we divide by 2, so where's cosine a half?
60.
That's a unit circle question. I'll encourage you again not to try not to use those sheets that you have in front of you on your homework because you won't have one on the test.
Wow.
Raw is right. Okay, it's a unit circle. Right there. So isolate the trig function and solve it. It's usually a unit circle question. If it is not, it's a calculator-based question. Okay?
What's the equation for?
So those are the basic
I didn't know what you're talking about. 1/2
questions.
60.
Okay.
And then it's
Mr. Arthur, can you write up the formula to, well, the equation to transfer radians to degrees? Just so you can get
Yes.
I gotta write it down every day. So I can remember it.
Radians times 180 over 5 equals degrees.
Thank you.
And degrees times pi over 180 equals radians. Conversion formulas.
Got only my units for food.
And I remember those only because radians has a pi. I need to get rid of it to get degrees.
Oh,
The pi's cancel, right? That will give me degrees.
okay.
That's how I remember it.
So,
Okay?
360 divided by 3.
Right, which is, okay, so that's how I remember the formulas. And the fact that I've been doing it for like 20 years helps. Right, okay. All right, let's step up just a touch. We're gonna have, yeah, this is a touch. You're gonna have to use your identities. And you're all very good at simplifying these. So if you have something like cosine x and tangent x equals a half.
Just guess.
Just guess.
Don't guess.
No?
Do the work.
No,
Think
we
it
just mean like usually for the identities.
No.
Whoa.
Listening.
Whoa. You're very hostile today.
I am not hostile.
Yes, you are.
I'm messing with you.
Still.
You just are receiving it very well.
It's because we're all tired.
I know, I can see
We
it.
don't want to be here, but yet we are.
So sine equals 1/2.
Why couldn't it be 25 degrees this morning?
Honestly, because then the roads would have froze and then boom. But nope.
So that's 30 degrees.
It had to be that
and
30 and
Okay, use an identity.
60 plus 90.
Remember we're still using those 4 items. Transfer to sine and cosine is 1, right?
exactly.
Right.
So let's transfer the sine and cosine
You're right, Jerry.
using an identity. What can I do with that?
You can cancel the cosine.
Cosines cancel out. So sine x,
5 over 6.
and where does that occur?
30 degrees and 150 degrees.
And I didn't restrict this, so use your free will on deciding to use degrees or radians because I didn't put an expectation up there on that.
5 over 6 and 5.
Okay.
Those numbers have to do the thing.
Okay with that? Which again, step by step, what can I do next? Okay, here's one.
Cotangent, 3 times cotangent. So we can
Square.
So again, isolate,
Get
right?
rid of the 3.
So add 1, divide by 3.
I think the 3
cotangent squared.
Is the cotangent isolated yet?
No.
No?
Cosine squared over sine squared.
Okay, so how do we get rid of squared? Square root of it. So cotangent x is
1 over root 3. So that makes tangent.
That means the
Yeah,
tangent
okay, there's another way to look at it. Cotangent's 1 over root 3, tangent
is just root 3.
is root 3. Okay, those are unit circle values.
Yeah.
So that means that it's
root
like
3 at like
30 degrees or 60 degrees.
Maybe.
Right?
No, I think it's always the ones that are half.
If this helps,
Wouldn't it be
where does sine have a root 3 in it and cosine have a
45
1
is
half?
45
This would be root 3 over 2.
and 1/2? Isn't it 45 degrees?
That's just wrong.
Oh no.
No, it's not.
30.
So it's 30 degrees.
Because what you have here is a half over
It's 30 and
root 3 over 2.
Right.
Okay. But you can read into that because of the root 3 and the 1. So, yeah, that happens at 30 degrees. Not 60. You say 60?
Yeah, 60 would be 60. That would be tangent, right?
Well, so this is a possibility, positive, positive. We could also have a negative and a negative to make this positive, right?
Oh, so
Pi over 6. 7 pi over 6. Which is 2 times.
which is 2
Yeah.
times. Just add.
Again,
I don't want to.
this is as much an algebra exercise as it is a trig exercise. Okay.
Too bad.
Questions here? Do you want me to show you one that uses an identity a little bit more heavily than this? Okay, last one. So these would all be considered, these are the easier. Okay, this would still be pretty straightforward. Another step up, this one would be considered kind of a medium. And this is where we have something like this. Cosine 2x equals cosine squared x minus 2. Bye-bye.
Did you divide by 2 first?
No one to add the or subtract the cosine squared.
Do these match at all? No match, right? Probably an identity. So is there an identity with cosine 2x
Yeah.
that has cosine squared in it?
Yeah, double A minus sine squared. Cosine 2A minus cosine, no, is equal to cosine squared A minus sine squared A.
Okay, that's one option. What's the next option?
The double A one.
Or it's 2 cosine squared A minus 1, or 1 minus 2 cosine squared A.
On your sheet, this is an identity. Now notice. We match. Now we can just add and subtract. Here we couldn't do anything. Now we can. So that's a little bit more of an advanced identity use instead of something like this. Pretty basic identity.
We can read both sides.
Subtract cosine squared. What's 2 minus 1?
1.
And then add 1, right?
Cosine squared
Is that possible?
maybe. No.
Okay, what's your next step?
Root both sides. You can't root it.
That's just I, isn't it?
No solutions. We don't do imaginary numbers with trig.
Do they?
We don't.
That's calculus.
Others might. It's called complex analysis. One of the hardest classes I took in college because you cannot see it. Like imaginary numbers, you can't see the mappings and graphs and stuff. I really struggled.
Yeah.
I was in my professor's office twice, 3 times a week. In order to maintain my grades on average, that's what I had to do. But, okay, so, again, if you can do those and those, you're in good shape. Okay, this is,
Extra.
it's not extra. I would love for you to be able to do it. Things we very rarely see at the next level.
Gotcha.
Tomorrow I'll show you a couple, or not tomorrow, Tuesday, I'll show you a couple more that we might see with some factoring. Okay, factoring with algebra and stuff, but. You okay with this? Take a deep breath.
It's nice.
You can do it. Okay. I'm gonna give you,
The weekend off, that's not gonna happen.
no, but I'm gonna shorten it. 5 problems. That look just, they are, like, I looked at the problems and I wrote these, because they look just like them. Okay? If, so that's gonna be due Tuesday. If you want to, I can put the rest up there and you can start
That'll be good.
on it. Yeah.
And then you also put Thursday, as a sign of stuff, because I'm not gonna be here Thursdays. And I'd like to get my head started.
I think they're already on top.
Yeah, they're already on class.
They should be up.
Thursday said a test or something.
Do Wednesday, do Tuesday. Okay? You can start the spiraling if you wish, I can, whatever. There you go. Because I know basketball, you guys, you have games Tuesday nights, so you might get a start on it.
So, Michael?